Hello, IB Bio students. Today we're going to continue topic 8.1 and we're going to learn about feedback inhibition. So let's start with the essential understanding. And the essential understanding states that metabolic pathways can be controlled with end product inhibition. So you're going to see these terms used interchangeably. So end product inhibition is the same thing as feedback inhibition, and it's the same thing as negative feedback. Now, what happens in this process? Well, this is a process where the final product in a series of reactions inhibits an enzyme from an earlier step in the sequence. So when this happens, that is going to ensure the levels of an essential product are always tightly regulated. So let's look at how this is done. So here we see a sequence of intermediates here, B and C. So here you have the initial substrate and here you have the initial product. And notice that the product itself is the one that is inducing a negative feedback because it's going to inhibit an enzyme at this particular step here. So what ends up happening is the product, D right here, it's going to bind to an allosteric site on this enzyme right here, and it's going to inactivate it. So this is what we refer to as non-competitive inhibition. So therefore the enzyme can no longer function and the reaction stops. So then the rate of the product is going to decrease or slow down. So this is very helpful because if the product levels build up, then the product itself is the one that's saying, hold on, too much product here. We are going to have to decrease the amount of product, and the product itself acts like a non-competitive inhibitor. Now, the other way around, if the product levels drop, then the reaction pathway will proceed unhindered and the rate of the product will increase. So if there's too little product, then the negative feedback mechanism is not going to happen, and then this reaction is going to continue unhindered. Okay. All right, so the application in this particular section is to understand the end product inhibition that converts threonine to isoleucine. So that's the one example that you have to learn. So a little bit about threonine and isoleucine. So isoleucine is an essential amino acid for humans. Now, we cannot synthesize or make our own amino acid. So we have to ingest it. We have to eat it. So food sources that are rich in isoleucine include eggs, seaweed, fish, cheese, chicken, and lamb. But in plants and bacteria, isoleucine can be synthesized from threonine in a 5-step reaction. So we got to learn what this 5-step reaction looks like in plants and in bacteria. So let's move further up here. So in the first step here, threonine is the initial reactant, and notice that it's converted to a few intermediates, as you can see here. Now it's regulated by enzymes, as all chemical reactions mostly are. And the first enzyme here that converts threonine into intermediate A, that enzyme is called threonine deaminase. So what isoleucine as the end product does, it will inhibit the enzyme. It's going to bind to that enzyme's allosteric site. So then the conformational shape of the enzyme changes, meaning the active site changes. So then the reaction is not going to be able to continue. So isoleucine in this case is again acting like a non-competitive inhibitor. Now, why is this important? Well, if you're making a lot of isoleucine, right? If you're making a lot of isoleucine, then that means that you're depleting the amount of threonine. So feedback inhibition ensures that isoleucine production does not cannibalize available stocks of threonine. So you don't want to use up all of your levels of threonine because threonine is also an essential amino acid. In your PowerPoint, you also have the same example of how isoleucine acts like a competitive inhibitor, and it inhibits, by negative feedback mechanism, the conversion of threonine. So here they show you with this model how isoleucine, being the product, is the one that's acting here as a non-competitive inhibitor. It's binding to the allosteric site of the enzyme. It's changing the active site of the enzyme. Therefore, the substrate, which is threonine, is not able to attach. So then that means that the reaction is not going to continue, right? So that's pretty much it for negative feedback inhibition. That's it for today.